Have you ever wondered if a single shot can disable a military tank without visible external damage? Welcome to the world of kinetic energy weapons, or KEWs, where the seemingly impossible becomes possible. Recently, Chinese scientists conducted comprehensive tests on the potential of these weapons against US military tanks. The results are quite fascinating. Picture a solid sphere, weighing about 20 kilograms, moving at a speed 4 times faster than sound. This might seem like science fiction, but it's the reality of kinetic energy weaponry. The kinetic energy carried by such a projectile is approximately 25 megajoules. To put this into perspective, if we were to convert this kinetic energy into electrical energy, it would equate to just over 7 kilowatt hours. This might not seem like much at first glance, but it's enough to power an average American home for about 6 hours. Now, imagine all that energy directed at a single point on a military tank. Despite the tank's tough exterior, the internal components would be subjected to a force they were never designed to withstand. Even though the tank might look unscathed from the outside, the damage on the inside could be catastrophic. The Chinese researchers refrained from naming the specific US tank model in their report. However, they did mention that the energy discussed would be sufficient to damage a 40 to 60-ton US-operated tank. This category includes the formidable Abrams tank, a mainstay of the US military. The high-speed kinetic projectile impact could lead to failure in specific locations of armored targets, surpassing safety limits recommended by the US military standard MILS-TD 810. This standard comprises a collection of testing techniques and protocols developed by the United States Department of Defense to evaluate the durability and resilience of equipment. So you see, a seemingly modest amount of energy can cause irreparable damage to the inner workings of a tank. This is the power of kinetic energy weapons, and it's changing the face of modern warfare. Now, let's dive deeper into the potential impact on US military tanks. The energy from these kinetic energy weapons, as discussed by the Chinese researchers, would be sufficient to damage a 40 to 60-ton US-operated tank, such as the mighty Abrams tank. Imagine a solid sphere about 20 kilograms in weight, moving at 4 times the speed of sound. This high-speed kinetic projectile could lead to failure in specific locations of armored targets, even without visible external damage. Let's consider the US military standard MIL-STD 810, also known as Military Standard 810. This is a collection of testing techniques and protocols developed by the United States Department of Defense to evaluate the durability and resilience of military equipment. The primary goal of MIL-STD 810 is to ensure that military hardware remains operational under diverse conditions it might face throughout its use. Now picture this high-speed kinetic projectile surpassing the safety limits recommended by this standard. The kinetic energy carried by such a projectile amounts to approximately 25 megajoules, a seemingly substantial figure that, when converted to electrical energy, equates to just over 7 kilowatt hours. Though seemingly modest, this energy could cause irreparable damage to the inner workings of a tank, even if the external appearance remains unscathed. Tank crews often position the front of the vehicle toward potential threats, aiming to leverage its rugged design. However, a kinetic projectile hitting this section could transmit destructive stress into the tank's interior, jeopardizing firepower capabilities. This concept of a high-speed kinetic projectile impact is not just theoretical, but is a looming reality, given the escalating race to advance hypersonic weapons. With defense systems often lacking the reaction time needed to counter such high-speed attacks, the potential of kinetic energy weapons becomes even more startling. The game of war is changing, and the advent of kinetic energy weapons may just be the tip of the iceberg in this new era of warfare. You might be wondering, how do these kinetic energy weapons differ from traditional anti-tank weapons? Well, traditional anti-tank weapons are typically powered by gunpowder, designed to penetrate armor by sheer force. But these high-speed kinetic projectiles? They're a different beast altogether. Their damage isn't just about penetration. It's about the shockwave they create on impact. A complex wave that can cause stress concentrations in unexpected places, like bolts, leading to distortions and fractures. And the methods of launching these projectiles are as diverse as their effects. They're not limited to a single firing mechanism, which broadens their utility across various scenarios. Now, assessing the damage caused by these kinetic projectiles isn't as simple as examining a piece of alloy armor post-impact. The entire tank has to be considered due to the shock wave generated upon impact. Indeed, the potential development of hypersonic kinetic kill anti-tank munitions seems likely, and the U.S. Army has been actively engaged in this pursuit.